In the rebuilding plans for the main school building, Appleby is looking to include a ramp access at the front of the school. According to the building code, the maximum slope angle is 5 degrees. From the main reception area to the outside road level, there is a 2-meter rise. How long would the run need to be? Draw a label diagram, part of your solution. So whenever we have a problem like this, we read through it, and typically we like to highlight what's important. So we have the 5 degrees, which is really important. We have a 2-meter rise, that's an important one in there. And we'll start by drawing a diagram. So it says that there's a 2-meter rise, so here's your 2 meters. And then what's going to happen is, if we vision this, the ramp's going to look something like that. So let's see if we can draw that a little straighter, shall we? There is our ramp. So we know the angle in here is 5 degrees, and don't forget to include that degree symbol. It's very important. Now, what do we want to find? We want to find how long would the run need to be. So the run would be the distance from the point here to here, and this is where labeling would be useful. So let's go A, B, C. So we want to find the run, and on my diagram I'm going to label that run X. So what I need to do now is I want to find the right trig ratio to use. So a strategy to do this is to do this. Write out the word SOHCAHTOA. So, and then we can make little check marks. So let's see. If I'm talking about angle A, X would be the adjacent. So I'm going to check mark each one that has an A in it. So I can discount sine right away because it doesn't have the adjacent in it. So next I look, what else? Well, I'm given an angle, so I'm going to check mark the C and the T because that's cos and tan of an angle. I would check mark the S as well, but we've already discounted it because we don't have the adjacent in sine. And then I look and I'm given this one, which is the opposite. The only case where I have all 3 checks is tan, so therefore I'm going to set this up using tan. So tan of A is equal to the opposite over the adjacent. So that means that tan of 5 degrees is equal to the opposite, which is 2 meters over X. Now I have to do some rearranging here. So X times tan 5 degrees. So what I've done is I've multiplied both sides of the equation by X. So now I'm going to divide both sides by tan of 5 degrees. Tan of 5 degrees is going to give you some number. So we just imagine dividing by that. It might be tempting here to type in tan 5 and get a decimal and use that decimal there, but we want to keep it as tan 5 degrees for as long as possible, because then when I plug it in my calculator, I'll get the most accurate result. So I'm going to type this in my calculator now. And so what we get, if we come up here, we get X is approximately, and it's important to know now it's approximate because we're going to get some decimals, 22.86 meters. Now, before going on, I'm going to ask myself, why do I feel good about this answer? Well, 5 degrees is a very small angle. It's opposite from a very small side. Angle B is my 90-degree angle, so this is the longest side. And I know since C is my middle angle, this needs to be my middle side. And we can see that 22.86 is a pretty reasonable number based on the relative sizes of the angles. So therefore, the run of the ramp should be 22.86 meters. And don't forget the statement at the end. Good luck.